Hi, welcome to the Shuko Math Practice Lab, Learning Through Practicing. We are still in the units. This unit is limit, continuities, and differentiability. We are in the practice set number 2. So the practice set number 2 basically is the kind of extension to the practice set number 1. We are still working on how to identify the discontinuity point and how to identify the intervals of where the function is continuous here. And in here, I have it divided into two parts. So the group number 1's problem is pretty simple. It's just basically give you a graph, and then we need to identify how do we write it out as the interval for the f is continuous. Then the next set of the problems here is, I give you the set of the functions here, right? And then we need to be able to show this function is continuous in all real number lines. Then the group 3, the two problems here is a little bit more complicated than the other one. I'm going to show you how to find the constants on those functions. Then we can define it so this function is continuous on the real number lines here. Okay, so now it's just as always, it's time, if you want to pause your video and get and the pencil and the paper and try to work some of these problems to see where you got stuck, and then come back and we can check the answer. Okay, so now if you want, you can pause the video, and I'm going to talk to you in the whiteboard. I'm going to stop this one and I'm going to the whiteboard now. Okay. Hi. Okay, so I hope that you got the chance to work on some of the problems, and now let's check our answers to see what whether you get it right or not, and hopefully we can help you to solve off some of your confusions here. And if you like the video, don't forget you can subscribe it, and also if you have questions, make sure you can leave me a comment, and I will be glad to answer your questions here. Okay, so as always, let's try to do a brief review about what we try to learn, and then we are going to go over that. We are still talking about the limits, and then we expanded the scope to the continuities here, right? So what is the relation? So we said from the practice number 1 here, a function in order to be continuous, they have to satisfy 3 things, right? So the things number 1 here, right? That means the limit x approach to a, f of x, this limit has to exist, right? So when you approach from the right-hand side, when you approach from left-hand side, it has to exist. Then the second conditions here, we said the function value of f of x at the point f of a has to exist. So this is the second condition. Then the third one, we say limit exists, the function value exists. That's not enough. In order to be continuous, we said the limit x approach to a, f of x, this limit has to equal to your function values here, right? So don't forget, those are the 3 guiding principles when we talk about limits and continuities here. Okay, now let's take a look at the first problem. First problem is pretty easy. So they give you a graph. This is the graph of f of x, and then we just want to write it out, the interval where the interval is continuous, right? So here, let's try to find our answers here. So the intervals are continuous. The first segment is here, correct? So you just start with -3. So this is a -3, and then it's all the way to where? The -2, but there's no value in -2, so it's an open parentheses. Then the second one's here, right? So the second one is from the -2. And then the values here, this value is continue going down, down. But it's very, 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 so x equal to the -1 is asymptote. So we know this one is continuous from -2 to -1. It still is open parentheses. Then the next intervals will be this one's here, right? So this one is from the here all the way to 0. So I know the next intervals will be what is -1 all the way to where? To 0, but it's what is close intervals here, right? Okay, now this part here, so let's take a look at this part. This part here is from 0 to 1, right? And both of them, they don't have the value at the 1. So here we say this is 0 to 1. And so the last segments is here, is this segments is here, right? So what is this segments here? This will be 1 to what? 1 to 3, right? So those type of problems are pretty straightforward. So you just need to be careful where the function value exists or function value does not exist, and then you can determine it is close interval, close parentheses, or open parentheses. And also because these ones here, if you still remember, right? So this is like a close at the -3. That means this function is a continuous from the right-hand side, right? So it's kind of like a review about what we did on the practice set number 1. Okay, so now let's take a look. The next set of the problem is to say, hey, I want to show, this function, both of those functions are continuous on the real number lines here, okay? So let's see here, how do we do that? So part A, so the function, the 1 minus x squared, so what is this? This is the polynomials, right? So we know the polynomial, this is a continuous. That's no problem. So where it continues here is a continuous from -infinity to 1, and it's a close bracket because the 1 is have equal signs here. Okay, so this is a continuous. Then the natural log x here, what is this function? This is a logarithm, right? So logarithm function, we also know the logarithm function is a continuous function. But where is the continuous to? From 1 to where? From 1 to infinities, right? So the only thing we need to show is at x1, is this is a continuous or not. So let's say here, so remember the guiding principles, right? So the limits has to exist. Okay, so the limit x approach to 1 from the left-hand side. So the f of x, it will be equal to the limit x approach to 1 from the left-hand side. So it's 1 minus x squared. So it's 1 minus 1 squared. So it's equal to what? It's equal to 0, right? Okay, now the limit x approach to 1 from the right-hand side, f of x, so it's greater than 1, so we use natural log, right? So x approach to 1, so we use the natural log x, so it's a natural log 1. So what is here? Here is 0, very good. We have a limit exist, right? So that's good news. And now that we want to see the function, so f of x1, so f of x1 is equal signs on the first function, so it's 1 minus 1 squared, so it's 0. So we know all these 3 equals, right? So all these 3 equals, so I know f is continuous, so I know f is continuous at x equal to 1. That's right. Now you combine this one, and this one. Now I can make the conclusion. I say f is what? Continuous at what? At the real number lines, right? From the negative infinity to the positive infinity. Okay, so now let's take a look at the next ones here, sine x. Okay, so the sine x, So this is what? This is a trig function. And we know the trig function is a continuous, right? So trig function is a continuous function. And what is a continuous to? It's less than pi over 4. So it's negative infinity to pi over 4. Open parenthesis. The same way, the cosine x, this is a trig function as well. And we know this is a continuous. Where is it continuous to? Because it's greater than or equal to, so it's a close bracket to the positive infinities, right? So the only thing I need to prove is add the pi over 4. So I say, okay, so now limit x approach to the pi over 4 from the left-hand side, f of x. Left-hand side is where? It's a sine, right? So it's this first functions from the left-hand side. So it's a sine x, so it's a sine pi over 4. So from your unit circle, what is pi over 4? Square root of 2 over 2. Okay, so limit x approach to pi over 4 from the right-hand side, f of x. So what is here? So this is limit x approach to pi over 4 for the right-hand side. So right-hand side is the second function. So it's a cosine x. Wow, pretty good, right? So it's a cosine pi over 4. So this is the square root of the 2 over 2. Very good. So our left-hand limit equal to the right-hand limit. So that's why my limit exists. Now let's check the function value. That means I need to check the f of pi over 4. So pi over 4, the equal signs, where is the equal sign? Equal sign is here, right? So that's why it will become cosine in pi over 4. So it's a square root of what? 2 over 2. Wow, that's good. So all these three is equals, right? So the is equal, so I can conclude f is what? F is continuous at where? At pi over 4. Okay, so now the same way you combine this, and this, right? So these three conditions, I can conclude f is what? F is continuous at from the negative infinity to the positive infinity. So it will be continuous at all real number lines here. Correct? Okay, good. Okay, the next problem is will be a little bit, a little bit harder. It's not too bad. So we still want to show, find the value. We want to find the C. So the f of x is continuous at the negative infinity to positive infinity, all right? Okay, so the same ways here, right? So the first things, let's try to find the function value at 2. Because both of them, these are the polynomial, so we need to worry about it is 2. So the 2's here, x equal to 2, the equal sign is here, right? So I need to use this one. So it's 2 to the third minus c times 2, correct? So 2 to the third is what? Is a minus 2c. Okay, so the same way, now I need to find the limit. So I will say limit x approach to 2 from the left-hand side f of x. If it's from the left-hand side, that means it's the first equations, right? So this will be c to the 2 to the square plus 2 times 2. So what is here? This is 4c plus 4. Okay, so the same way I would say limit x approach to 2 from the right-hand side. If it's right-hand side, will be the second equations. So that will be 2 to the third and minus c times 2. So it's a minus 2c. So by our continuity definition, this one, and this one, they all has to be equals, correct? So that means a minus 2c will be equal to 4c plus what? Plus 4. And what you get here, 4 is equal to the 6c. So the c is equal to the 4 over 6 over 2/3. Okay, so that's why I said, okay, when the c is equal to the 2/3, then these functions will be continuous on the whole real number lines here, right? So this one is a little bit of several extra steps, basically try to solve for the c. So it's not too bad. Let's take a look at our last problem. This one is a little bit more complicated than the previous one. As we said, you know, my problem typical, so I will start with the easiest one and gradually go to a little bit harder, right? Okay, so now let's take a look at this one here. So first, let's try to find the limits here. So we have several couple jumping points, right? I have a 2, I have a 3. Those are the jumping points here. Okay, so let's take a look. Limit x approach to 2 from the left-hand side, all right? F of x. So this is a limit x approach to the 2 from the left-hand side. Left-hand side is smaller than 2, so you use the first equation. So this is x squared minus 4x minus 2. Oh boy, if you substitute 0, what do you have here? You have 0 over 0. So like we learned in the limits units, we need to manipulate this expression. So we said, okay, let's try to factor. So try to see if we can factor out our trouble terms here. Then it turns out, well, pretty good. X minus 2 cancel out. So what I have here, I have here is what? Is 4, right? Okay. Okay, now let's here, so limit, now x approach to 2 from the right-hand side. The f of x, that means x is greater than 2. That means I'm going to use the second equations, right? So this is ax squared minus bx plus c. So this will give you what? A to the 2 squared minus b to the 2 plus c. So what I have here, 4a minus 2b plus c, right? 4a minus 2b plus 3, I'm sorry, there's no c's. Yeah, there's no c's here, I'm sorry here. So this is 3. Okay, so this is 3. Okay, so this is 3. I don't know why I wrote a C there. Okay, so here, this is 3. Okay, so plus 3 here. And the same things here, I want to find the function value, f of 2. So function value, because equal signs here, I use the second equation. So it's a2 squared minus b times 2 plus 3. So it's 4a minus 2b plus 3. And based on the continuity definition, this number has to equal to this number, has to equal to this number. So I have the first ones here. So what is the first ones here? So I will have a 4a minus 2b plus 3 is equal to what? Equal to 4, right? So this is my first one. Okay, now I'm going to work on the next jump here. So let's take a look. Limit x approach to 3 from the left-hand side. From the left-hand side is smaller, so that will be second equations, right? We did this a lot in the limit practice here, so hopefully you will be very good at it, right? So bx plus c, so this will be a to the 3 to the square minus b to the 2 plus c. So it's 9a minus 2b. I use the c again, so it's 3, haha. Okay, so plus 3, so it's a plus 3, okay? So the limit, now I go to the limit from the right-hand side. F of x is greater than, so I go to the third equations. So this is limit x approach to 3. So this is 2x minus a plus b. right? So the 2x will be 2 times 3 minus a plus b, so equal to the 6 minus a plus b, correct? So the same way, the f value, the function value f3, the equal signs here, so I will have used the third equations, right? So this will be the 6 minus a plus b. So the same way as the continuity definitions, these two has to be equal. So I come out with the next equation. So it's 9a minus 2b plus 3 is equal to what? 6 minus a plus b. Okay, so these are the two equations. We have two variables. We have a and b. So let's simplify it a little bit so we can solve it. So the first one is this will simplify the 4a minus 2b and move the 3 over, so this will be 1. And this one we can simplify a little bit, move the a over, we have 10a, 10a, move the b over. Okay, so the move the, oh, I'm sorry, here, this is the 3b's here, I don't know. Okay, so here, this is 3b, careless mistake, right? Okay, so this is 3b. Okay, so then move here, this will be minus 4b, and simplify this one's here, and then this one, this will be 10a, move the b over here, minus 4b equal to 3. Okay, equal to 3. So now I have two equations and two variables. Then in order to solve it, what I can do, I can times the first one. I can use the elimination methods here, right? I times the first one, let's say negative 2. So it's negative a, then plus 4b, negative 2. So it's negative 2. Then add back to the second equations here. I got an a. 2a is equal to 1. Very good. So I got an a is equal to 1/2. Okay, so when you get an a equal to 1/2, you can substitute back to your original. So this is 4 times 1/2 minus 2b equal to 1. So what I have here, so I got the b equal to 1/2 as well. Okay, so that's what we solve it. So when a is equal to 1/2 and the b is equal to 1/2, if these two conditions satisfy, then the f of x is what? Is continuous at negative infinity to the positive infinity. That means they are, f of x is continuous in the real number lines here. Okay, so that's it. The problem number 4, the part D, problem number D is a little bit tedious, but, we follow the basic concept, right? So when the limit and the continuity, remember the 3 things we need to satisfy. Okay, that's it. If you feel this is helpful and if you feel like you can always, subscribe to my channel. That would be great. And also, if you still have some questions, feel free to send me a comment and I will try to respond to your comment. It is so nice to talk to you. And so I will talk to you in our next practice set. All right. So don't forget practicing, practicing, practicing. That will make you getting better in math. Okay. And talk to you later. And bye.